Next important topics is lipids. Okay, and in the lipids, the basics are pretty high yield. In the basics, 1 gram of lipid yield. So what question will be asked regarding keratin sulfate? Most common gag present in your eyes is your keratin sulfate. So 1 gram of lipid yield how many calories of energy? First important MCQ. 1 gram of lipid yield how many calories of energy? 1 gram of lipid yield approximately 9 calories of energy. So lipids and 1 gram of lipid yield how many calories of energy? 9 calories per gram. Okay. Apart from that, classification of lipids are pretty important. Classification of lipids are pretty important. In that classification of lipids, I'm going to write you simply what are the things you need to know. Your lipids are classified into basically 3 types. Your lipids are classified into basically how many types? 3 types. And what are they? Come on, simple lipid, compound lipid, simple lipid, compound lipid, and derived lipids. And derived lipids. So what are simple lipids, what are compound lipids, and what are derived lipids? That's a pretty important one. We have to know your simple lipids containing just the triazyl glycerol. Just the triazyl glycerol. That is so called a simple fat. That is 3 molecules of your fatty acid, free fatty acids are getting attached with your glycerol backbone. 3 molecules of your free fatty acids are getting attached with your glycerol backbone. And your compound lipids are again classified into 2 types. One is your glycolipids, another one is your sphingolipids. Glycolipids, another one is your sphingolipids. So what is the glycolipids and what is the sphingolipids? So glycolipids are the one, okay, we can write it in this pattern, glycerophospholipids. Phospholipids and sphingolipids. I can write it instead of glycolipids and sphingolipids. I can write phospholipids and sphingolipids. So what is a phospholipids? Your triazyl glycerol. Glycerol will be on the backbone. Glycerol will be on the backbone, plus a free fatty acid attachment will be there. So this gives a simple lipids. And apart from that, is there any other compound? For example, nitrogenous bases, or for example, any other substances like phosphatidyl inositol. So whatever the any other substances which get attached with this glycerol free fatty acid complex, then they were called as phospholipids or glycerophospholipids. Phospholipids are glycerophospholipids. And sphingolipids, instead of backbone glycerol, you will have a sphingosine. Instead of backbone glycerol, you will have a sphingosine. So sphingosine plus free fatty acid plus any other attachment. Plus any other attachment is no gives rise to sphingolipids. Okay. Next important thing is your derived lipids. So whatever the structures derived from this simple and compound lipids are your derived lipids. Simple and compound lipids are your derived lipids. So for example, glycerol, free fatty acids, and cholesterol. So whatever the cholesterol, free fatty acid, glycerol, sphingosine, these stuffs are known as derived lipid. Most commonly, we will discuss about the free fatty acid and cholesterol. So you know the structure of cholesterol. That is not nothing specific here. Your free fatty acids are classified into 4 types based on the chain length. Based on the chain length. So what are they? Very long chain fatty acid, long chain fatty acid, medium chain fatty acid, and short chain fatty acid. Very long chain fatty acid, medium chain fatty acid, long chain and short chain fatty acid. So based upon the chain length. So some books, different books says a different value. So I don't want it to go before with the numbers, but I wanted to say you that these are the important content. So let me say you, and based upon the your free fatty acids are again classified based upon the nutritional value. Based upon the nutritional value. So what is the based upon the nutritional value classification? They are classified into 2 types. One is your essential fatty acid and non-essential fatty acid. Non-essential fatty acid. In that essential fatty acid, we have 2 types of essential fatty acid. One is your omega-3 fatty acid, another one is your omega-6 fatty acid. What are the omega-3 and what are the omega-6 fatty acids? Your omega-3 fatty acids are, number 1 is your cervonic acid. Number 1 is your cervonic acid, which is also known as docosahexaenoic acid. Docosahexaenoic acid. This docosahexaenoic acid is present in breast milk. Very, very important MCQ. And number 2 was your timnodonic acid. Timnodonic acid. And number 3 is your alpha linoleic acid. Sorry, lenic acid. Alpha linolenic acid, or your omega-3 fatty acid. And what are the omega-6 fatty acid? That is linolenic. That is a gamma linolenic acid, linoleic acid, and arachidonic acid. Arachidonic acid. This arachidonic acid is responsible for the synthesis of prostaglandins. Synthesis of prostaglandins. And this linolenic and linoleic acid are present in sunflower and safflower oil. Sunflower and safflower oil. Sunflower and safflower oil. Okay, these are the important. Apart from that, you have an important glycolysosomal storage diseases. I will discuss about the main one here. So I told you sphingolipids. You have a sphingosine as a backbone. Yes or no? The sphingosine will combine with the free fatty acid, and the sphingosine with the free fatty acid, the structure is so called as ceramide. Okay, the structure is so called as ceramide. Very, very important MCQ. So when the sphingosine binds with the free fatty acid, then the structure gives rise to ceramide. If there is an attachment of your phosphocholine, then it is called as sphingomyelin. Then the sphingolipids called as sphingomyelin. If there is an attachment of sugar, then it is called as cerebroside. Are you getting it or not? You have a sphingolipids and we are enhancing the structure of sphingolipids. So sphingosine plus free fatty acid plus additional substances. I told you when I was doing a sphingolipids. Yes or no? Yes or no? So the sphingosine plus free fatty acid are combined to form a ceramide, combinedly called as ceramide. The additional substances, if the additional substance is a phosphocholine, then the structure formed is your sphingomyelin. If the additional substance is a sugar, then we call it as cerebroside. Then we call it as cerebroside. And this cerebroside plus NA gives rise to ganglioside. The cerebroside will combine with the NA and gives rise to gangliosides. Okay. So what happens is, so what do we call this? Sphingomyelin? Sphingosine plus free fatty acid plus phosphocholine. So the sphingomyelin is degraded by the enzyme called as sphingomyelinase. The sphingomyelin is degraded by the enzyme called as sphingomyelinase. Now this deficiency of sphingomyelinase causes Niemann-Pick's disease. Very, very important MCQ. Niemann-Pick's disease. In Niemann-Pick's disease, there will be accumulation of sphingomyelin. In Niemann-Pick's disease, there will be accumulation of sphingomyelin. Why do the sphingomyelin is really important? Because the sphingomyelin is a constituent of what? It is a constituent of, because the sphingomyelin is a constituent of your pulmonary surfactant. Now this pulmonary surfactant is secreted by what type of cells? Again, faster. Pulmonary surfactant is secreted by what type of cells? Type 2 alveolar cells. Type 2 alveolar cells are type 2 pneumocytes. Is sphingomyelin alone as component of a pulmonary substances? Is sphingomyelin alone a component of your pulmonary surfactant? No. So type 2 secretes a pulmonary surfactant, and the pulmonary surfactant contains dash and dash. What is the another substance? Pulmonary surfactant pulmonary surfactant contains two components. One is your sphingomyelin, another one is your myelin and lecithin. And this lecithin is also known as dipalmityl phosphatidylcholine. Dipalmityl phosphatidylcholine. What is the main purpose of this pulmonary surfactant? Helps in the fetal lung maturity. Helps in fetal lung maturity. So when will the pulmonary surfactant started secreting or synthesizing? It started synthesizing at 28th week of intrauterine life. 28th week of intrauterine life. And what should be the lecithin sphingomyelin ratio in order to determine the fetal lung is matured? LS ratio should be greater than 2. LS ratio should be greater than 2 in order to check whether the fetal lung is matured or not. Whether the fetal lung is matured or not. If there is a no lecithin or no sphingomyelin, no pulmonary surfactant. When there is a no pulmonary surfactant, there won't be any fetal lung maturity. Then what happened? The fetus will develop, the fetus will develop NRDS, neonatal respiratory distress syndrome. Neonatal respiratory distress syndrome. So you should be very, very careful about this entire concept, people. Pretty important concept. So in Niemann-Pick's disease, so what happens in Niemann-Pick's disease? There will be a sphingomyelinase deficiency. When there is a sphingomyelinase deficiency, what happen immediately? Sphingomyelins will started accumulating. Very, very important MCQ. Now we have what? Now we have seen a sphingomyelin degradation. Now this gangliosides can be degraded by your hexosaminidase A. Now this gangliosides can be degraded by your hexosaminidase A or B. Aminidase A. I rather go for the A def. Hexosaminidase A def causes Tay-Sachs disease. What disease? Tay-Sachs disease. Okay. Hexosaminidase A def causes Tay-Sachs disease. And I told you, your ceramide plus sugar forms a cerebroside. And if the sugar can be either a glucose or a galactose, this sugar can be either a glucose or a galactose. If it is a glucose, the cerebroside will form as a glucose cerebroside, and glucose cerebroside. And if it is a galactose, then it is called as galactocerebroside. Galactocerebroside. Yes or no? This glucose cerebroside is broken down by the enzyme glucocerebrosidase. Glucocerebrosidase. This glucocerebrosidase enzyme deficiency is seen in Gaucher's disease. What type of disease? Gaucher's disease. Gaucher's disease causes what? Glucocerebrosidase deficiency. Glucocerebrosidase deficiency is caused due to is present in Gaucher's disease. And this galactocerebroside can be broken either by the two enzymes. One will be alpha galactocerebrosidase. Another one is your beta galactocerebrosidase. And this alpha galactocerebrosidase deficiency causes Fabry's disease. What disease? Fabry's disease. And beta galactocerebrosidase deficiency causes Krabbe's disease. What disease? Krabbe's disease. Okay. And now, what are the important features of this Gaucher's disease? Two things. Histopathologically, you will see the wrinkled paper appearance. And this cell is called as wrinkled paper appearance, and the cell is called as Gaucher cell. And in the X-ray, you will see the Erlenmeyer flask deformity. Erlenmeyer flask deformity.